multiplication and the lattice algorithm. The lattice algorithm is based on partial products, so let's look at an area model with partial products of 24 times 36. I'd write 24 in expanded form, here, and 36 in expanded form. And I'd subdivide my rectangle into regions that represent the areas. I'd have a 20 by 30 region, 4 by 30, 20 by 6, and 4 by 6, and then I would add the 4 partial products. I can look at this with manipulatives, and if I were to spread out the rectangle, you could see that I would have 4 regions, and the 4 regions correspond to the partial products. We're going to start building up our lattice algorithm from this picture. The first thing I want you to notice is the way I recorded the expanded form. Instead of writing 2 0, I wrote 2 10s, because in this algorithm we're just going to focus on the digits. We're not going to add in our zeros for 20. Looking at my manipulatives, I can group them in sets of 10, so I can take 10 rods, 2 sets of 10 singles, and 10 rods again, and then replace them. 10 rods here became a flat, the 10 singles became a rod, and so on. Now I want you to notice I've very intentionally located the groups of 10 in the upper left part of the grid region. So my groups of 10 went in the upper left part. Over here we didn't have groups of 10, so it's empty. Now if I draw in diagonal lines here, you can see that within a diagonal I have matching manipulatives. My ones, my tens, my hundreds, and this would be my thousands up here. So this is really important because we are grouping by place value. Most of our algorithms are based on place value. So if I draw my lattice structure, we can see that here I have my ones. In the next diagonal, I have my tens. Here I've got the hundreds. And then finally up in the corner here, I would have the thousands. So our grouping here is along the diagonal. So when it comes time to add, when we want to see how many tens we have, 6 tens, I'll add along the diagonal because I'll be adding like valued parts. Let's go ahead and actually solve this using the algorithm. So if I wanted to do 24 times 36, I would draw a rectangle, label the sides 24, 36, build the lattice structure, and then start multiplying. So I could multiply in the upper right region 4 times 3, and I get 12. And then I can move to my lower right region. Now I have 4 times 6. I'm just taking the cross section here. 24. Upper left, 2 times 3 gives me 6 with nothing up here. And then finally in the lower left, I'm going to take 2 times 6, and I'm going to get 12. Then it's time for me to add. Now how do I add? I add like valued parts. So I want to add the ones. That's 4. Then I add along the diagonal to get the tens. 2, 4, 6. The hundreds, that's going to be 8, and I had nothing in the thousands. So my answer is 864. Now some people record their numbers on the left here like this, and then just read along here, 864. We're not limited to two-digit numbers here. For example, if I did 247 times 59, I could set up my lattice, label the sides, do all of the partial products, and then it comes time to add. So my ones, I have 3. My tens, I have 6 plus 6 is 12, plus 5 is 17, 7. Carry the 1. My regrouping to the hundredths, I'll have 8, 11, 14, 15, regrouping, I'll end up with 4 and 1. So my answer is going to be 14,573. And that is the lattice algorithm.